All right, gonna do a quick little video here about Le Hopital's rule. So you can see this guy is French. This is our best picture of him. The French part is only interesting, right, because you have to try to pronounce his name, and it's Le Hopital. It's a rule about finding limits. Okay, so it kind of belongs in chapter 1, but you will see you need information from later in this course to be able to apply the rule. Okay, so this only works if you have these indeterminate forms. And I'm going to probably argue that these are the only two, the first two here, that you're going to actually see the 0 divided by 0 and the infinity over infinity, where you can apply the Hopital's rule. So it's pretty basic. It's like if a limit is indeterminate, right? That means it falls in this list. Then you can calculate, specifically if it's f over g, this is only for quotients that look like that, by doing the limit, the same limit, except you can take the derivative of the top and the derivative of the bottom, right? And the corollary to that says that you can just keep going. If you take the first derivative and it doesn't work, then the corollary says, well, you can take the second derivative of each term, right, and calculate the limit that way. So let's look at how this works out. So in example 1, we've got, we have what we have. So if we plug in the 3 immediately, that's what we would ordinarily do to calculate this limit, right? And we get 0 on top, of course, divided by 0 on the bottom. So this means that Le Hopital's rule applies. So you're free to go ahead and do it. So we're going to rewrite this limit. Instead of doing x minus 3 for the numerator, we're going to take the derivative of that, which is just 1. And we're going to take the derivative of the bottom, which is just 2x. And we're going to recalculate this limit that way. So we'll plug in 3 there. Holy geez, we get 1/6, right? And you would see if you work this problem out the old-fashioned way, as we'll call it, right? You would have actually factored the denominator, canceled out those terms, and then re-plugged in 3 to the expression that remained, right? And you still get 1/6. So it all works out great, okay? Let's try example 2. I'll kind of switch colors here. So let's plug in 0 and see what we get. So we have e to the 0, which is 1. Okay, we have indeterminate form. So that's enough to allow us to go ahead and we'll take this limit and we'll change the top to the derivative of this, which is 3e to the 3x. And then the bottom, the derivative of x, is just 1. So now I can try to plug 0 into that. And I end up with 3e to the 0 power, which is 3. Right? You weren't going to get that originally until this rule came along. Okay? Let's try another one down here. This one has the limit approaching infinity. Okay, so let's see what happens here. I'm probably going to just rewrite this with a positive exponent, right? The e to the negative x just means that you can write it as e to the x and put it in the denominator. And then plug in my infinities and try to reason about what this might be. Okay, my suspicion here is that we have 2 different size infinities, right? The denominator's infinity is humongous. And the numerator is taking the square root of infinity, which is obviously much smaller than raising e to the power of infinity. So, since it's indeterminate, I'm going to go ahead and take the derivative of it and see what I get. Oh, hello. Let's try infinity here. So, remember that the square root of x is x to the 1/2 power. And hopefully we've kind of recognized that the derivative of that is 1 over 2 root x for the numerator. And the denominator is e to the x, right? Now I can kind of combine these expressions, right? And basically I have 1 over 2 root x times 1 over e to the x, which is 1 over 2 root x. Well, I probably wouldn't write that first. I would probably do this first, and then take the limit as x approaches infinity of that. So now we have 1 over 2 times infinity, and we know that 1 divided by a humongous number is 0. So that actually ends up being 0, if you can believe it. Just crazy. That's showing you how humongous the denominator, right, with a power of infinity in the exponent is compared to the original numerator. Okay, last guy, let's go orange here. Important to go ahead and plug in 0 first, just to always verify. Oh geez, so it's not indeterminate, right? And that means that this actual answer, you can actually go ahead and divide 0 by -5, right? And your answer would be 0. So always double check that it is applicable, right? With that indeterminate form first, and then go ahead and start applying the rule. Thanks.